All right. I've titled this presentation Understanding How Seasons, Perspective, and the Sun's Movement Points to a Flat Earth. Some of these observations are going to be things that you may have seen already. This is primarily for newcomers and perhaps a refresher to get back to the basics for some of the more seasoned flat earthers, as it were. All right, let's get into this. The purpose of this presentation is to share my thoughts and personal observations in order to help people get a better understanding of where they live. By better understanding where we are, we can better understand who we are and who we are not. As the heliocentric cosmology teaches us that everything came from a godless Big Bang, flat Earth cosmology, on the other hand, teaches that we are in a system that has been created and that we didn't evolve from monkeys and all that nonsense that comes along with the globe model, that your life actually has value, that you're more important than just a speck of dust in infinite space on some spinning ball in a vast, endless universe. Okay. Connecting the dots. Seasons on a flat earth. We're going to cover that first very briefly. The sun's movement on a flat earth and your visual perspective on a flat earth. Okay, this is the 1892 Gleason standard map of the world. I lean towards this map because it makes sense to me based on my personal observations. And you may have known that back in 2018 that I took a trip to Alaska to ascertain some information about flat earth, and we'll be covering that a little bit later. But this will make sense to me because, well, I mean, it shows what we know, that most of the earth is covered in water and, you know, pretty much how it's set up there. It also works pretty well with the flights on Earth, and where we've seen examples of emergency landings taking place where it wouldn't make so much sense on a globe. It actually fits very well with this particular model. But what I want to point to is in the lower left and right hand corners are how it explains the movements of the sun and the seasons here. So the June solstice. In the figures June and December, the white represents the sun's position in his respective months at noon. This shows sunlight inside the Arctic Circle for 24 hours. From June 21st, the sun moves round the tropics in a spiral circle, widening every day until it reaches its destiny on the southern or outer solstice on December 21st. Meaning basically that the sun makes a clockwise circuit, and each day that circle that the sun makes around the North Pole gets a little bit wider until it reaches, its highest position, the outermost position, that is December 21st, winter solstice, which they cover here. On December 21st, the sun moves around the Tropic of Capricorn and during the day lights up the southern portion of the Earth from the Arctic Circle to some portion of Antarctic ice. There is no sunlight 80 degrees south, but unknown regions of ice. On the 23rd of December, the sun commences his southward journey, again returning to his starting place, and thus completes his seasons. So when the sun circles around to the farthest edge out there, the circle begins to contract again, coming back to this position on June 21st, and it just continues like that. Spirals from December 23rd back inward. From June 21st starts to spiral back out, and it continues that kind of timekeeping motion there, because the Earth acts as a massive timepiece. And it kind of flies in the face of the idea that all this originated from an explosion from nothing. Like, explosions don't create such order and predictability in a system. So that's another thing that kind of casts doubt on the idea of the heliocentric model. Now, while we're about to wrap up seasons on the flat Earth very, very quickly, like I said, I want to turn your attention to timeanddate.com. We use timeanddate.com. There's a feature, it's the day and night world map. It shows the position of the sun and the moon on Earth real time, all the time. and I like that feature because I've used that during eclipses and other periods just to see, okay, if I can see the moon here, who else can see the moon at the same time? Things like that. Same thing with the sun, and we'll cover that in a little bit. But also, this kind of gives away the idea of the sun and the moon not being the sizes and distances that we've been told, because on this model, the sun and the moon act as a spotlight. Like, they're not, the sun's not 400 times the size of the earth. It's not 93 million miles away. The moon isn't, 4 times smaller than the earth and 239,000 miles away. Both of these luminaries are small and local, and they act as a spotlight as they make these circular paths over the face of the earth. And that's depicted here, as you can see, the sun and moon acting as a spotlight. Now, I like this because this is a video that was done by a channel called The Buzz Dev, and they took the data from timeanddate.com, and they plugged in that data from 2016 and created this model, and they put that data onto the flat earth map, and it just shows the path of the sun and the moon. I'll leave a link in the description for this video if you want to check it out. I believe they've done other models using the information from timeanddate.com, but this is something that really resonates with me because it's the real-time information that we're getting from timeanddate.com applied to the flat earth map. So I just wanted to share that with you. All right, let me see. Okay, so here I'm going to show you once again my trip to Alaska. You've probably seen this already, and just wanted to show you again that whole clockwise circuit. That's what I went there to prove, actually. So you saw that tower there. You see the sun moving off into the distance, and then what we just saw there, there was points where the sun was off in the distance and then came right back. So simultaneously saw sunset and sunrise at within hours of each other. So I thought that was pretty cool, but we'll talk about that a little bit later also. And there were times, of course, where I had to turn the camera and point it upward because, as the sun got closer to where I was at, it got higher in the sky, so I had to make adjustments. I didn't want to change. I didn't want to switch scenes. I wanted it to be, a continuous video, just so there was no wiggle room for anybody to say that I manipulated anything. So that was the starting point right here. That tower right there at Murphy's Dome, and then you saw the sun make a clockwise circuit. I did, in fact, have to move my camera around in a circle to follow the sun, and then it came back to its original position, just like it says, on the map. Now, another thing that I did while I was in Alaska, I also took pictures every hour of the sun. So I wanted to show the azimuth, the degrees, the direction it was traveling, and all that, and I wanted to show the time. Now, this was June 21st. It was 1:03 or 1:01 a.m. Okay? At this time, while I was in Alaska, the thing that blew my mind, okay, the most profound thing, actually, about being there, being able to witness the 24-hour sunlight, was that anyone on Earth that could see the sun, okay, from anywhere on Earth, I could see the sun at the exact same time that they could. Okay, so right now, what we're looking at right now, this picture, seeing the sun in the distance at 1 a.m., the sun was actually over the Middle East, or what's called the Middle East. It was noon Eastern Africa time over the Middle East. So 2 a.m., I could still see the sun right there, and the sun was over North Africa, or Central Africa. Central Africa time, it was noon Now, high noon, that's when the sun is the highest in the sky. So it was high noon in Africa at the exact same time that I could see the sun while I was in Alaska. So thought that was pretty cool. Same thing. 3:02 a.m. I still have my eyes on the sun at 3 in the morning, and we didn't really break from being able to see the sun at that point. So I could get out, look, and I could see the sun at the exact same time that it was over Africa. So I thought that was pretty cool. But like I said, anytime that anybody else on Earth could see the sun, I could see the sun at the exact same time. And to me, in my opinion, the way that the Earth is set up observably, how the North Pole star Polaris stays in one spot seemingly, and we're told that it moves from time to time, or that another star has been the North Star and all that. We haven't experienced that, but we've been told that, so that's fine. But we see the stars in these time lapses all make these concentric circles around the North Star, and that, in my opinion, would be an ideal place for the creator to sit and look down on the earth. you know like it just kind of clicked into me, into my mind while I was there. It was a mind-blowing experience. If you can make it to Alaska this summer at some point, I'd encourage you to do so. So again, just a brief view of what that looked like. Okay, I kept my camera locked onto the sun, showed that the sun was making a 360-degree circuit around the North Pole, and this is the time period from that data that was taken from timeanddate.com, showing 24-hour sunlight in Alaska, closer to the North Pole. All right, so that's the sun's movements on flat Earth. Now let's talk a little bit about your visual perspective on a flat Earth. Now, this is an example of a little art project that we've all probably done, an art project, something like this. And this is from like a sixth grade art class, something like that. And this is the point perspective. Okay, what you would do, you would draw a point, on the paper, and then all the lines, the lines from the street, the lines from the sidewalk, the lines from the buildings, they would all converge into the vanishing point. And a lot of us remember taking this class and actually doing this project. At least I know I do, and I've talked to a lot of other people who have. So why would they have us do this art project this way? Well, that's because that's how your eyes really work. In reality, your eyes function just the same way. Your vision it's shaped like a cone, if that makes any sense. Okay, wherever you look, there's a point out in the distance, and all lines converge into that point. Okay, just like if you're standing in this hallway. This is the hallway, I believe, of a cruise ship. Now you're standing in this hallway and you're looking down, and you see the walls going inward, you see the floor, it seems to be going upward, and the ceiling seems to be going downward. And you know that the hallway is the exact same size at the other end, but your perspective shows you that the further away that all the distance is, as things get further away from you, the smaller they become, and they all converge into the vanishing point. Okay, so another example of that is street lights. Now, this street light that's really high right here, okay, let's try to imagine that as the sun around high noon. Okay, and then in the distance, as the sun goes away, that would be visualized as sunset. Now, if this road continues 10, 20 miles away, and the street lights are constant, just same height, same brightness, it's gonna look like those lights kind of set into the horizon. So let's move on from here. All right, here's another example of street lights. All these street lights are the same height, same distance apart, but as they go away, they look like they're getting lower on the horizon. So what I did, I took sunset, what I used to do after work every now and then, I'd go to a nice relaxing spot, watch the sunset, and I've done live streams from this place, and I would record the sunset. Okay, and it becomes blatantly obvious to anyone with sense that I was sitting still, and obviously it's the sun that's moving, it's not the earth that's moving. So what I did, I kind of faded the picture of the street lights with the sunset just to show the exact same thing. The sun maintains a constant altitude, and as it goes into the distance, it appears to set into the horizon, but it just goes further out of your view to a point to where you just can't see it anymore, and it takes its light with it. So that's pretty much how that works. All right, still on perspective, and let's cover this. Fantastic. All right, let me see, about 9:03, Bradford, Yorkshire. Let me see here. Where's the sun right about then?
Where it is now, Dale, mate, it is just in the distance. It's just over the hill. You can see it just about in the distance there.
All right. That's awesome.
See it.
Beautiful sunset.
So it's just about over the hill, but you make out the rays about still.
Yep.
And behind me, you've got darkness.
That's awesome. Here, I'm in Tacoma, Washington right now. Check it. I got the Tacoma Dome back behind me in the distance. And then you can see the Tacoma skyline back here over the city. So that's where I'm at, and we're looking at the same sun. That's fantastic. All right. Well, I appreciate you participating in this project. And
hey, that's fine.
Thank you, sir. You have a fantastic... My man Luke, how's it going?
Yep.
Fantastic, sir. Here, about what time is it?
It's 6:06 a.m.
6:06 a.m. And what's your location, sir?
I am in a small town called Biloela in central Queensland, Australia. I'm standing outside of the Callide Valley Lions Park, the corner of the Dawson Highway and Cooper Street.
Awesome. That's fantastic. All right, so that's the time, location, and you can see the sun out there. It's about sunrise.
I'm in a bit of a valley, but the sun's just coming up over to from memory, I think it's about northeast, about 60 degrees. That's just off the top of my head, but...
All good. All right. Sounds good. I am currently in Tacoma, Washington. Got the sun right above my head right here, as you can see. Okay. So that was from a project I did back in 2017, I believe it was. And on that video call, as you saw, I was in Tacoma, Washington. It was 1:03 in the afternoon. I called Matt in the UK, and the sun was setting. It was 9:03 p.m. Then shortly after that, I immediately called Luke in Australia, and it was 1:06 my area, and it was 6:06 in the morning. So what we experienced there was an example of what we're seeing here. Okay, it is possible that, well, here, you just have to imagine from your perspective on the plane, all right, wherever the sun is, if you're looking in the distance, you see the sun coming up. That sunrise over there on the right. High noon, obviously, is when the sun is the highest in the sky, and then when it's going down, that's sunset, if you can visualize that. But that's what we all experienced at the same time, you see. It was 6:06 a.m. where Luke was, high noon where I was at, the sun was high in the sky, and then it was sunset at the exact same time where Matt was. But you also recognize that it makes sense that we were all standing on a level surface. We're all standing on a level surface at 90 degrees looking at the same sun, and the sun's at a constant altitude. Matt's watching the sun go down. The sun's above my head. Luke's watching the sun come up. Okay? Nobody was upside down. You see? All right, so about to wrap this up. The Here's another example. This is the movements of the sun, visual perspective, and all that. Kind of all culminating here. So this is an example of the streetlights again. Sunset goes down, then sunrise as the sun's coming back up, and then high noon. So again, real quick, I just want to show you this from the beginning. Okay, hold on. We started this at 11 p.m. Okay, what you're seeing right now is the sun setting. The sun sets, and then we just witnessed sunset right there in those 5 seconds, and then this is sunrise. The sun's coming back up closer to where I am, and appears to rise from my perspective, but the sun's maintained a constant altitude the whole time. Okay, so here we are. This is sunset, and then shortly after, sunrise. So it just depends on your perspective and your position on the plane. All right? Does that make sense? I really hope that makes sense. And then, there was the point of high noon where the sun's high in the sky, and I had to tilt the camera upward to get a good view of it. Okay? All right, so just going to wrap this up here. I hope that made sense. For all those things to kind of connect, to give you a better understanding. So reality makes more sense when you can understand the progression of the seasons, when you understand the movement of the sun, and understand the perspective and the way that your vision works. All right. Just wanted to share that with you one more time. These are things that I probably covered before, but not exactly in this format, and not all tied together. But I hope this helps. If you enjoyed the video, give it a thumbs up. If you feel that it'll be helpful, then by all means share it. And that's all I got for this one. As always, be good to each other. Take care of yourself. Stay flat. I'll see you next time. Thank you.